Ready?
Yeah, no.
We're in the room.
We're in the room. Okay. This video, we're going to go through part 1 of semester 2 for quadratics. We're going to be looking at expanding brackets, yes? And what else are we looking at? We're looking at expanding brackets like woo. Okay, so you need to expand brackets. You need to also expand brackets using perfect squares. So doing that, we need to look at the difference of perfect squares. We need to solve things using null factor law. So that's what we're going to do. Now the first one, remember what method are we using when we're doing this? FOIL. Now FOIL, how many letters are in FOIL?
4.
Which means that how many terms are we going to have when we expand brackets like this? 4. Shh. Thank you. 4. So what I do not want to see is people just go, this is x squared plus 20. If that happens, I will lose my stuff. Okay?
Wait, why? Why can't we do this?
Well, because F stands for
Oh, we have
first.
to actually write the line.
No, you don't have to, but what I don't want to see is that you have two expressions, because there's first, outside, inside, last. So there's 4 things. Now, we know that if I multiply 4 times x, that's going to give me 4x, and 5 times x, that's going to give me 5x. So I then can simplify those two things. So let's do that. X times x is x squared. 4 times x is 4x. 5 times x is 5x. Thank you, I don't need a running commentary.
Sorry.
And 4 times 5 is 20. Now we do have 4 expressions, and we always can simplify. If you do not simplify, you will not get your marks. You will lose at least half a mark. I can guarantee you that. So 4 and 5x are like terms.
Not cool, mate.
4 and 5x are like terms, so we collect those, and we are done.
Wait.
So x squared plus 9x plus 20.
So let's do this one. X times x is x squared. X times 3 is 3x. Minus 7 times x is minus 7x. And minus 7 times positive 3 is negative 21. It's about time, we're in year 9 now, that we can accurately multiply two negative, or a negative and a positive and negative. So if you are making these mistakes, you need to get these fixed pretty soon. Otherwise you're going to have some problems going into year 10 and 11 maths. Now, of course, we're not quite done yet, because we need to collect these like terms. X squared minus 4x minus 21. Now, this is where I noticed a lot of you made many mistakes, and that's when I don't have an x, I have a coefficient to x, like in this case, which is 3x. Now, 3x times x is, well, 3 times x, just the number 3. So that is 3, but x times x is x squared. So it's 3x squared is the first term. And then the next one, 3x times minus 6. What is 3x times minus 6? Negative 18x. Very good. And then we're adding this one, 8 times x, which is 8x, and 8 times minus 6, which is minus 48. We collect like terms, and the only like terms we have, once again, repeating ourselves, but they're always those, if you have in this sort of format, these two are going to be the like terms always. So therefore it's 3x squared. Now that's minus 18x plus 8x is minus 10x. Very good. Minus 48. Rupert, you had a question? So,
Isn't that the same as the one just above it?
Similar. Okay, so with this one, 4x times 2. Now, some people added 4 and 2. Remember, it's 4 times 2, which is 8x
Squared.
Thank you for the running commentary.
It's alright.
Okay, I'm then going to do that one there, which is 4x times minus 9, which is minus 36x. Minus 3 times 2x is minus 6x. And then minus 3 times minus 9 is what?
27.
Positive 27, because it's two negatives.
And a negative equals a positive.
Thank you. Okay. I'm collecting those like terms, and then now be careful though. Remember, you might want to, until you get good at this. Remember that on a number line, if I had a number line and I have a number line, this is 0 and this is -6. If I'm subtracting 36 from -6, I'm going that way. So it's going to be -42. -42x plus 27. Now I'm going to very quickly do these. 3x times 4x is 12x squared. 3x times 1 is 3x. We are done. -7 times a is a squared. -7a times +7 is -49a. Now, when we're expanding, this is a different one, expanding perfect squares. Whenever you have this, what would you do? Can someone put their hand up and tell me, what do? You actually square both. So it's the same thing multiplied by itself. So what you actually do is you write it out like this. Don't get lazy. Because what I see a lot of students do is they go, okay, I'm just going to square this. And then I'm just going to square that. And there you go. Voila. No. You can't do that. I don't know what that voice was, but anyway. Okay, now y times y is y squared.
That was like the super wog
Y times 2y. I don't know if it was a Mexican or what it was. Plus 2y plus 2y.
It's 4y. No.
Y squared plus 4y plus 4. That's done. It's actually easier than the other ones we've been doing, but what a lot of students do is they don't expand it out. They don't get those two brackets multiplied by each other. Same thing over here. We're going to write out two sets of brackets, x times x minus 3 by itself. That is a perfect square. So it's x times x, which is x squared, x times minus 3, which is minus 3x, minus 3x again, and be careful, -3 times -3 is +9, which gives us x squared minus 6x plus 9. Now, what does this sort of thing, what is this thing that I've just pointed out here or circled? What do we call it? I'm going to revert back to the to your skills audit here. Expand brackets using the difference of perfect squares. Now, difference of perfect squares is something like this, and what's interesting about that is you still get your 4 terms, but the middle terms cancel out. So you're only going to get the x squared part in this example, and you're going to get a number. The 2x's are going to cancel out, and you will see why, because it's the difference of perfect squares. You're adding 2x, you're subtracting 2x, for example. So they're very straightforward, they're very easy, but a lot of students mess these up as well. So a times a is a squared. A times minus 6 is minus 6a. 6, then we're adding 6a. And then we're subtracting 36. What's the number always in difference of perfect squares? The number is always what? Is it always positive or negative? Negative. It's negative. It's always negative. You will never get difference of perfect squares and expand them and get a positive number there.
So the number always is negative.
That is exactly right. Is that what I just said? Yes. Yes, it is. Okay. A squared minus 36. These two guys, they cancel each other out. They obliterate each other. Okay, kaboom. Now, this is another example. Can you see how this is another difference of perfect squares? But the coefficient is 2 of A. So let's try this. What is 2A times 2A? I'm going to get you to do this very quickly. I'm going to pause this video, try it. So if I was to say to you, and it's good to see, 2a times 2a is 4a squared. Remember, it's 2 times 2. I see a lot of students doing this. They get 2a squared. 2 times 2 is 4. That's okay. Let's make the mistakes now, not in your test next week. All right, that's why we're here. 2 times minus 3 is minus 6a. And because it's a difference of perfect squares, then we're also going to get that 6a cancelled. They're going to always cancel when you see that difference of perfect squares. Then it's minus 9. So therefore the answer is 4a squared. Oops, minus 9. 4a squared minus 9. All right. Now, if I was to go back to this, your skills audit, the only thing that we need to look at is solving quadratic equations using the null factor law. Can someone please shout out, what does the word null mean? We refer to zero. So therefore we've got an equation equaling 0. Okay, so let's go ahead and very quickly look at some null factor laws. Now, be careful. Make sure you show you're working, because if you screw up, you can actually get some marks. What I'm going to say is that this is already set to 0, so that's good. That's what we're looking for. We can't use null factor law if we don't have equals 0. We might need to rearrange the equation if that's the case. So what that means is that x is equal to 0 or x plus 3 is equal to 0. That's what we've got in here. So now what we've got to do is, in order to do that, x equals 0 is nice and easy. That's done. That's one of our solutions. We've solved one of our 2 solutions. Because it's a quadratic, we have 2 solutions. Now the other one is what? X is equal to? X is equal to negative 3. Thank you. There you go. We've just solved that using null factor law. What about the next one? We've got 2 things which are multiplied and they give a result of 0. So therefore 5x is equal to 0. Or x minus 2/3 is equal to 0. Okay, so what does that mean? What does that tell us? What is x then? One of our solutions is x equals 0. We're going to circle that. And then the other one is x equals plus 2/3. Add 2/3 to both sides, and then so it doesn't. We're not always going to get nice round numbers, whole numbers. You did in year 7. Okay. Yeah. Did someone have a question?
Could you times
Yeah.
the 3 and the 2/3?
Can you times the 3 and the 2/3? No, because you need to, because you're actually subtracting 2/3, April. Okay. So you need to add 2/3 to both sides, and then you've got your answer there for you. George, did you have a question?
Is it positive 2/3 because you've taken it to the other side?
Yes, that's right. Yes. All right. Now, just quickly, null factor. You can. I'll have to suss out whether it's the CAS, because otherwise you can do everything in your CAS.
Exactly.
It might just be a scientific calculator. Shh. All right. This is as hard as null factor law gets for you guys at the moment. What I'm going to do is, this means that 3x minus 5 is equal to 0, or x plus 2 is equal to 0. Then what I'm going to do is we need to solve for x. So what we're going to do is, just like anything, we need to add 5 to both sides. So 3x is equal to 5. And then I'm dividing both sides by 3, which gives us x is equal to 5/3. Now remember, that's only one part of the problem. You're going to have 2 solutions. The other solution is nice and easy though. We could guess and check here, couldn't we? What do I have to add to 2 and get a result of 0? Negative 2. So therefore the answer is x is equal to negative 2. Nice and easy one. And this last guy over here, 11x minus 7 is equal to 0, or 2x minus 13 is equal to 0. So what we're going to do is, over this side, I'm going to add 7 to both sides, so that's going to give me 11x equals 7. X is equal to, dividing both sides by 11, 7 over 11. 7-Eleven. Open 24 hours a day. Except for the one in Thornbury. Closes at midnight. Stupid. Okay. That's right. Okay, 2x minus 13. So let's do this. 2x is equal to 13. And x is equal to 13 over 2. There you go. I have my 2 solutions. Are you ever going to get 3 solutions for this? Are you ever going to get 3 solutions? No, because it's a quadratic and there's only ever 2 solutions. We'll go into occasions where there's 1, but not yet.
So for the one with
No more than 2. No more. Yep, these are 2. Absolutely. Now, these ones, it says here, into standard format. We won't worry about those because we're going to finish soon. So I'm going to stop there, but guess what? Guess what? With 3 minutes to spare, we have just been through your skills audit. Do you reckon we could solve quadratic equations using null factor law? Yeah. There you go. I reckon we could check that box as well. I reckon we could check that box. So today, what we've done in today's lesson is we've done this, we've done this, we've done this, we've done this. That's pretty much what to expect. All right, I'm going to stop.